Now let's move on to calculating the arc length. So we will go straight to this result of calculating the arc length. Here it says, if a curve C is described by the parametric equation, that is this one, say for example, we can represent the unit circle, that means the circle with radius 1, right? And if the two limit points are, the coordinates with which the parameter runs are mentioned as alpha and beta, with the derivatives to be continuous. And then if C is the curve obtained by this representation of the parametric symbols, then the length of the curve is at once given by this formula. And there's another important word here saying that C is traversed exactly once. I will explain the meaning of that in a little moment, but just for the time being, let's try to apply these conditions for this result, right? So basically what we have is alpha and beta. They are the starting point and the end point of the parameter. When it's like if you have a certain curve in the x and y coordinate, and if you need to find the arc length of this curve, then this alpha and beta are not the starting point and the end point of the x-axis, right? They are not alpha and beta, they will be a different number, but this alpha and beta represents the corresponding parametric value for these starting point and the end point. Okay, so now let's say if you have this unit circle, right, that is represented by this parametric format. So if we draw the plot, let's say if we start t at 0, you will get this 0 point, not 0, you will get this 1, right? Now you can see that there is a small red dot at the 1 0 point, right? And by increasing this one, let's say if we increase t up to 1, you will get this, right? And let's say if we increase t up to pi by 2, no, it's pi by 2, you will get this part of the circle. And likewise it will keep on increasing, and if it is 3 pi by 2, you will get 3/4 of the circle. And if you have 2 pi, if it is pi, you will get the half circle, and if you get 2 pi, it will complete the full circle. That means you start from here at theta equals 0, and by increasing theta, this curve will traverse this distance and come back to the starting point at theta equals 2 pi. So in between these two parametric values, the curve has completed one full cycle. So if you need to find the length of this one full cycle, you should do the integration in between 0 and 2 pi, because those are the alpha and beta values given in this result. Now it is not a must for these curves to be a closed loop like this. Okay, you can even use it to find the arc length of these kinds of curves as well, right? The only requirement is you should use the appropriate parametric values for these lower and upper limits, right? And we did in section 8.1, we did a different formula to calculate the arc length, and there we did not involve any parametric representations, right? But here we have a separate equation to compute the arc length or the length of the given curve when you know the details of parametric representation, right? So here we have alpha and beta, and then you just have to get the square root of dx dt squared and dy dt squared. Now be careful, this is not the second derivative, okay? You are just squaring the first derivative, so you just have to differentiate these two terms. That will be this one, and then upon squaring the two terms you will get this one, right? So that means the integral will be equal to this, and the answer will be equal to 2 times pi. Now anyway, we already know that if you have a circle with radius r, the circumference is given by 2 pi r, right? So in this case of unit circle, r is equal to 1. Therefore, from those relationships, we can anyway get the arc length of this circumference, right? So and there's another thing. This is not the only way to represent the unit circle. You can even write down the unit circle as x equals sine 2t and y equals cos 2t. Even from this one, if you square it, you will get the same relationship. That means even from this representation you will get the unit circle, right? But let's try to apply this representation in this formula. So when you have these x and y values, then dx by dt will be equal to 2 cos 2t, and dy by dt will be equal to 2 negative 2 sine 2t, right? So then if we directly apply it in this result to compute the given arc length, right, then it will be 0 to 2 pi and 4 times cos squared 2t plus 4 times sine squared 2t, right, and the square root, right? Then it will be equal to 0 to 2 pi and 2 dt, and when you solve this one you can see that the answer is equal to 4 pi, right? See, now here we have the same curve, but the length of this thing is obtained as 4 pi, but the correct length should be equal to 2 pi, right? Because from the usual geometry also we know that the circumference of the circle should be 2 pi, and we also found it from this representation. So where did we make the mistake in this computation? Now that is related with this traversing exactly one case, right? The problem here is that if you consider these two endpoints, we will be completing the circle 2 times, right? Remember, I did this example in a previous video as well. Now see here, if we choose 2t as the parametric representation, when see, if it is pi divided by 2, it will complete a half circle, right? So if it is pi, it will complete the full circle. That means when now if this is the plot, when theta is equal to 0, you will start from this axis, and when theta is equal to pi by 2, it will be completing a half cycle, right? and then at theta equals pi, it has completed the full cycle. So if we keep on increasing theta, you will be tracing the same curve once again. So that means it's like it has now, suppose you are running across this curve, right? So it's like you have completed one full cycle, and then once again you are going to complete this full cycle one more time, right? It's like you have traveled this distance 2 times. So that's why you are getting 4 pi as the answer. Therefore, we must be careful when you assign these values. Although you have the picture like this, you should be careful about the number of times that it travels. Okay, so if you need to get the correct answer here, you should have pi as the upper limit. Then you will get 2 pi as the answer. That means the length of this curve, right? And also now, yeah, so that's all for this video. The very important thing you should obtain, understand from this one is there is another rule or a result to obtain the arc length. Now in section 8.1 also we did a result to obtain the arc length, but there we did not use any parametric relationships. So if we have the parametric relationships, we can use this result, but we have to be careful with these alphas and betas, right? The alpha and beta represents the starting and the end point of the endpoint value of the parameter, this third variable. And also now in cases like this, you should be careful to eliminate these these cases where it travels more than once. Otherwise it will be counting those number of times as well.